So here you can see the standard LedControl library running. But as you can see, it's much too slow because of how it's been programmed. The bigger the display is, the slower it gets. So internally, LedControl maintains a transfer buffer for however many matrix modules you have, up to the maximum of 8. So if you have 4 modules, it has 4 16-bit values as a buffer. If you have 8 modules, it has 8 16-bit values as a buffer. And anytime you do a transfer, it will start off by blanking this buffer and then setting opcode and data on the one matrix element that you want to send an update to. And then it will proceed to send the whole buffer, the empty ones as well. They contain a no-op, and it will send them until it reaches your chosen element, and then it will continue to send so that the whole buffer is sent. Now this means that if you want to update all the elements, you have to call this routine to update first one element by sending no-ops to all the others, and then continuing down the line, sending more data to the next element while all the others get no-ops. So if you have a row of 8 elements and you want to update all 8 elements, it means that the other elements will receive 56 no-ops. So out of 64 16 bits of data sent, only 8 of those actually contain data for updates, while the other 56 blocks contains no-ops. But that's just one row. You have 7 more rows. So 8 rows in total and 64 updates per row makes 512 updates you have to send out. That's 8,092 bits, and only 1,024 of those bits contains anything meaningful. And it's doing all this using Arduino library routines. You know, the digital write and shift out. And those are not small at all, they're quite big routines. They are big because beginners use them and they're supposed to be safe for every kind of use. But in this particular use is just horribly inefficient. Very, very slow and horribly inefficient. So how are we going to fix this? Well, we have to start by not sending no-ops, only sending useful data. And then we have to stop using the library routines to do the bit bashing. So after working a couple of days on this, this is the code I came up with. It's a simple small routine that just bashes out 8 bits of data on the pins selected. With every update of the display for each of the 8 rows, I call it for each of the matrices, once with a opcode and once with a value. Link to the full source is down in the description. So let's finally see what this looks like. And here we can finally see the display running with the optimized code. It's a bit too fast. But after adding a 30 millisecond delay and hitting upload again, and it's running very smooth now. Very nice.